In this question, it is given that the coefficient of friction between C and the ground is 0.5 and the coefficient of friction between A and B is 0.25. But the important thing which I am pointing out is the fact that coefficient of friction between B and C is 0. Which means if we are applying any force on block B, then block B will not apply any friction or any other force on C. Therefore, C will not move at all and block B will slide on a frictionless surface. So this is a actual two block problem, and these two blocks will only move and C will not move as there is no friction between B and C. Now we have to find out the value of F for which the sliding will begin between A and B. So this makes a very easy question, and we have to apply our steps. And step 1 says that we have to find out the acceleration of the system. Now system is of only these two masses A and B because they both are moving only. Now therefore we can say that the acceleration of the system will be F upon 6 because their combined mass is 6 kg. Now we, with respect to step 2 says that with respect to block B, the free body diagram of A has a mass of 2 kg. This is A. So with respect to block B, I am drawing the free body diagram of A, and a force of MA is acting on this A, which is a pseudo force in the backward direction. So pseudo force will be MA. M is 2 and A is F by 6. And the maximum friction which can act between them will be equal to mu mg. So mu is 1 by 4 and m will be 2 and g will be 10. So F max will be equal to 5 newtons. Now F by 3 is equal to 5 and F will be equal to 15 newton. This is the minimum required force for sliding between A and B. So this was a very easy question. Now we move on the next question. In these kind of questions in which there are three blocks which are placed one over another, we face some difficulty to solve these kind of problems, and I am demonstrating a simple method to easily solve these problems. So please pay your full attention on this video. So there are three blocks as you can see, A, B and C, and all the coefficients of frictions are given and the value of maximum friction is already being calculated by me, and I have written that value on the surface itself. Now we need to find out the minimum value of F for which the sliding will occur between B and C block. Okay, now first of all, before anything we should consider them as a system and we should find out the acceleration of the system. So step 1 which we say is A system will be equal to the external force acting on these three blocks as a system will be F, and the friction acting from the ground will be in the backward direction, it would be 16 newtons, and the mass of the complete system will be 8. So A system will be equal to F minus 16 by 8. I have already written that. Now this is the first step which we have to apply before anything, and after that we have to assume that let us assume that sliding occurs first between A and B and B and C moves together. I'm finding out the value of F for which the sliding is occurring between A and B, and I'm assuming that at this time B and C are moving together. So I'm drawing the free body diagram of block A. So this is block A. It has 2 kg mass, and a pseudo force will be acting on this block A because I am in the frame of reference of B and C. So pseudo force will be acting in the reverse direction, and its value will be Ma into system. So F minus 16 upon 8 into the mass of the block, which is 2. So this is the pseudo force, and the friction which will prevent the sliding will be acting in the forward direction. Its value will be 2 newtons. So F minus 16 upon 8 will be balancing, will be equal to 0, and F will be equal to 16 Newton here. So this force F, which is 16 Newton, is required so that A and B slips before B and C. Now another case I'm considering, that assuming that A and B moves together and sliding occurs between B and C. A and B are moving together and sliding is occurring between B and C, and I need to find out the value of force for this condition. So I am drawing the free body diagram of 4 kg with respect to A and B block, and therefore a pseudo force will be acting on this 4 kg in the reverse direction, which will be equal to Ma, and M is 4 and A is F minus 16 upon 8. Okay, now if the sliding is occurring between B and C, therefore the friction of B on C will also be in the forward direction. Its value will be 24 Newton, and as C will be moving in the right hand side direction, therefore the ground friction will be acting on C in the left side, and its value will be 16 Newton. So 4 F minus 16 upon 8 will be equal to 24 minus 16, which is 8, and F minus 16 will be equal to 16, and F will be equal to 32 newtons. So if B and C slides before A and B, then the required force will be 32 Newton. So we know that the lesser force is required in the first case. So we can say easily that hence this is the conclusion. Hence we can say that A and B will slide before B and C. So A and B will slide before B and C, and at the moment when we have to find out the minimum horizontal force F, which is required to initiate the sliding between B and C, so at that moment when B and C were on the verge of sliding, then A and B will already be in the sliding mode. Therefore all these frictions, all these three frictions will be acting to their peak values, and hence now I am erasing this part. Now I'm just a minute. I do not prefer to go on the blank page. I can go on the next page, but I don't prefer that, because the connection of the question and its diagram will be not present on that page. So I prefer to do the question on the same page. You can go back in the video and you can watch if you have any problem in the previous concepts. Okay, now I know that A and B will slide before B and C, and when B and C will be sliding, then A and B will be already in the sliding mode. Therefore, all these three frictions will be acting to their limiting values, maximum values, and hence if I find out the acceleration of block B, I have to draw the free body diagram. This is block B. It has a mass of 2 kg. This is block B, and I am finding out its acceleration with respect to ground, because I know that there is slipping occurring on all the surfaces, so I can find out the accelerations with respect to ground. So the force acting on this block B, F, is in forward direction, and it will be going with the fastest velocity. So both the frictions will be acting on this block in the reverse direction, F1 and F2. Okay, so its acceleration will be A, let's suppose. Then A will be equal to F minus F1 plus F2, and F1 plus F2 will be 26 newtons, and upon mass is 2 kg. So this is the acceleration of block B. And now for sliding between B and C, so I am drawing the free body diagram of C with respect to block B. So with respect to block B, the FBD of block C, this is C, I am drawing the FBD, and the pseudo force will be acting in the reverse direction on block C, and it will be equal to 4A, and A will be equal to F minus 26 by 2. And the friction acting on C from the ground will be also in backward direction, which is 16 newtons, and the friction acting on C due to block B will be in forward direction, which is 24 newtons. So 2F minus 26 will be equal to 24 minus 16, which is 8, and F minus 26 is equal to 4, and F is equal to 30 Newton. So a minimum of 30 Newton force is required to initiate the sliding between B and C, and at that time all three blocks will be sliding on each other, and the third block will be sliding on the ground also. So this is the basic concept of these three block problems. Obviously these are somewhat lengthier than the two block problems, but this method can easily be applied in any kind of these three block problems. I'll come up with more three block problems in my next videos. Thank you. In this question, we are given three blocks A, B and C, and their masses are given, and the coefficient of frictions between all three surfaces are given to us, and we need to find out the least possible value of F, so that any part of this system of three blocks starts the motion. So we need to find out that least value of F for which any part of this system will start the motion. So first of all, we should find out the value of maximum frictions of all these three surfaces. For this surface, I am writing F1 max. So it would be this 30 kg mass MA into G into mu1. Mu1 is 0.3. So it is 90 newtons. You can calculate it. For this surface, F2 max is equal to the sum of masses A and B, which is 40 kg, and the coefficient of friction is 0.2. So 40 into 0.2 into 10. So it is in fact 80 Newton. And for this mass, for this surface, the normal reaction will be due to the all three masses. So 30 plus 10 plus 20 is 60, and the coefficient of friction is 0.1. So 60 into 0.1 into G is 10. So it is 60 newtons. F3 max. Now if we apply at least 60 newtons, then sliding will occur and the system will move together, and all three blocks will move together, because these two frictions are sufficient to move this block B and C, because C is facing this friction as a opposition, and C is being moved by this 80 Newton. So 80 Newton will move the C, and this 90 Newton will move the B. So I can say that if I apply a minimum of 60 Newton force, then this system of A, B and C will move together on the ground, and on increasing this force further, then sliding will occur one by one on these surfaces of the blocks. So the answer of this question is option number A. Thank you. In this question, there is a system of three masses which are placed one over the other, and the friction coefficient between any two surfaces is given as 0.25, which is 1 by 4, and this pulley and strings are massless, and block A is connected. This block A is connected with a rod. So this is a rod. So this is sure that block A will not move in any of the direction. And in first question, we need to find out the value of F, which is required to move the block C with a constant speed. So if we draw the directions of motion, then we can see that if this block will move in this direction, then surely that B block will move in this direction. Now, if B will move in that direction shown, then the friction acting on the block B due to A will be in the backward direction. A will apply the friction in backward direction. F1 max. I'm writing that friction as maximum because sliding is occurring, and friction will be the maximum friction. Now this block C is moving towards left side, and this block B is moving towards right side, and C is moving towards left side. So C will be applying a friction on B towards left side, and C will be trying to drag the block B. So the friction of C will also be acting towards left side. Now this will be the tension of the rope. Now if C is moving with a constant speed, let's suppose V, therefore B will be also moving with the same constant speed, because the pulley which is connecting these two blocks is at rest. So for the constant speed, if V is equal to constant, then we can say that F net force will be 0. So this tension will be balancing out F1 max plus F2 max, and the value of F1 max will be mu into mu is 1 by 4, m is 3 kg, and g is g. So 1 by 4 into 30, as well as the friction between B and C will be 3 plus 4, which is 7, into mu is 1 by 4 into g is 10. So T will be equal to, this is 70 by 4 and this is 30 by 4, and this will be 100 by 4, and it would be 25 newtons. Now if we draw the diagram of block C. So this is block C. So C is moving towards left side like that, and the force F is applied towards left direction. The friction of the ground acting on the C will be towards right side. So this is F3 max, obviously because sliding is occurring. So maximum friction will be acting on the blocks, and the friction which B will apply on C will be towards right side again. This is F2 max, and there will be a tension force also. So also, if V is constant for this block also, the net force will be 0, and hence F will be equal to F3 max plus F2 max plus T. So F will be equal to F3 max will be 3 plus 4 plus 8, which is 15 kg of mass, and mu is 1 by 4, so 15 into 1 by 4 into 10 plus F2 max, we have already calculated, it is 70 by 4 plus tension is 25 newtons. So this is 150 by 4 plus 70 by 4. So 150 by 4 plus 70 by 4 will be 220 by 4, and 220 by 4 will be 55. So F will be equal to 55 plus 25, and this will be equal to 80 newtons. So the correct answer for the option number 1, for the question number 1 will be option number C. Okay, now if F is 200 Newton, then we have to find out the acceleration of block B. Now if F is 200 Newton, then we can find out the acceleration of block C, and for that F, I'm writing the equation of block C. So I'm writing for block C, the direction of forces will be shown as this only, and for block C, F minus F2 max minus F1 max minus T. Now T will be a different one as was in the previous case. So that would be equal to MA, and M of C is 8 and A is A. Now for block B, I am writing for block B, the equation will be T minus F1 max minus F2 max, and that would be equal to MA. M will be 4 and A will be A. So this is the equation number 1, and this is the equation number 2. Now if I'm erasing that. If I add up these two equations, 1 plus 2, then tension will be cancelled out, and the equation will be F, which is 200 newtons. So I'm substituting the value 200 minus the friction acting on block C will be F3 max, in fact. So it is F3, sorry. So 200 minus. Now 200 minus 2 F2 max. So F2 max is already equal to 70 by 4. So it would be 70 by 2, which is 35 newtons. So this is 35 Newton, and minus this F1 max, and F1 max is 30 by 4, which is 15 by 2, and F3 max is also equal to 150 by 4, which is 75 by 2, and this will be equal to 4 plus 8, which is 12A. Now this is 200 minus 35 is 165 minus this 15 plus 75 will be 90, and 90 by 2 will be 45. and it is equal to 12a. So 165 minus 45 will be equal to 120, and that is equal to 12a. So a will be equal to 10 meters per second square. So the correct answer should be option number B. Okay, now we move on the next question.